It is perhaps difficult to tell on screen, but this is not a cylinder. It's actually kind of like a cone that's been chopped off at the bottom. So I don't know why I would care about the dimensions of my cup, but pretend that I did. And so I have this lovely, I'm going to really exaggerate it, right? It's like it was a cone, but then it's been chopped off, and this part is my cup part, and that's the part that was at the bottom that's someone chopped off. I don't know why. And maybe what I really would like to know, so I've got my cup, and I can measure for my cup what the radius is at the top and what the radius is at the bottom. I'm just going to randomly estimate that and say that this is 2 inches and this is 3 inches. And I can measure the height of my cup and say that my cup is 9 inches. But what I'd really like to know is what got cut off the bottom, right? If this really was part of an entire cone, I know this is like the lamest example. No one would ever actually care about this, but it's what I had sitting in front of me. So I'd really like to know, what is this height down here? So it turns out that looking at this, we can call this a similar triangles problem. Now, that similar word just means that we've got triangles that share the same angle. So if I come in here and I think about, I've got this big triangle here and this smaller triangle here, and they share some angle theta. You probably saw similar triangles in a previous life, but I'm going to approach it perhaps differently than you approached it before, because I'm going to throw some trig review in here. So when I think about similar triangles, I actually think about them from a trigonometry perspective. So if that's my angle theta, I'm looking for which trig function goes with the sides that I have labeled for this triangle with an angle of theta. Anyone want to type in the chat which trig function would go with these two sides? If I just highlight this triangle here, that's an angle theta. That was a 2 and an h. Which trig function would go with these two sides? Awesome. Thank you for Haley for giving us our trig function here. So I know that for this small triangle, that tangent of theta would be the opposite side over the adjacent side. So I'd be looking at 2 over h. Now, if I come up to our larger triangle, this giant thing, so this giant thing still had that angle theta. This side was 3, but this side of my triangle was actually h, the part that got cut off, plus the 9 inches of my cup. So this whole side is h plus 9. And if I think about setting up what tangent of theta looks like for this triangle, if I stick with tangent theta, I've still got an opposite over adjacent side, or 3 over h plus 9. Now the cool thing about trig, because I know these two angles are the same, those triangles share them, that's why they are similar triangles, tangent theta for this triangle has to be equal to the same value as tangent theta for this triangle. But if I'm putting the same angle in, then I had to get the same value here. So that's what allows me to say 3 over h plus 9 is equal to 2 over h. And the truth is that if we had just started this as a similar triangles problem, That's probably where you would have written one of these ratios anyway. I personally find it easier to think about all the similar triangles problems as really being trig problems. So I just figure out which trig function do I need for the sides of the triangle I have. So for example, if I didn't have this h side, but I actually had a length over here, I'm just making something up. I'm just going to pick a letter. Then if I had these two sides, I would say, oh, I'm going to set this problem up in terms of, well, there I've got my hypotenuse and the opposite side. So I would set this up in terms of sine theta. But to keep this back, to try to loop back around to answer that original question. So if I'm going to have to solve this to get h by itself, there are a bunch of different ways to do that. I see some people that are already writing. So I'm going to give you 30 seconds to see if you can solve for h on your own. So the way that I would approach this problem, and I saw someone suggested cross multiplication. I'm sure we mean the same thing. What I'm going to say is I'm going to eliminate fractions by multiplying by something to make them go away. So if I need the h in the denominator to go away, I'm going to multiply both sides by h. And if I need the h plus 9 in this denominator to go away, I'm going to multiply both sides by h plus 9. The net result of that should be the same as cross multiplication, right? So this h over h, we could say they cancel out, but somehow cancel out sounds like 0 to me, and it's not going to be 0. H over h is 1. So I like to write a giant 1 instead of just crossing it out. H plus 9 over h plus 9, again, that is going to be a giant 1. So on this side, I'm going to be left with 3h. And over here, I'll be left with the 2 and the h plus 9. I didn't leave myself a ton of room to write here, but by the magic of an eraser, I'm going to distribute that out. So I'm looking at 2 times h plus 2 times 9, and I'm going to get 2h plus 18. And finally, if I subtract that 2h over 3h minus 2h, I'm going to be left with just the 18 that folks were typing in. And I didn't lose sight of it. Someone in there asked me the name of my cat. I feel like this should be a scavenger hunt item. The name of my cat is findable in Canvas. So I'm just going to leave that to you and see if someone can figure out the name of my cat by the time we meet again on Tuesday.